have been working on natural interaction for quite some time. So interacting through touch or touchless control is something that I'm really passionate about. And one of the projects that I worked on very rigorously over the last 6 months was improving the multi-touch capabilities on the Android platform. So we all, at least most of us, kind of love Android. I know there's a lot of competition as far as iOS and who's better. I hate to say this, iOS is definitely better as an application development platform. And you'll see why. A little about myself. I am an electrical and computer engineer. I finished my engineering in 2007, and I was building electric cars and God knows whatnot, until I realized that's not what I want to do with my life. So a friend of mine, who's a good friend of mine now, also the CEO of the company, met me at a conference where I was presenting some of my research on natural interaction. And we got together and started this company, which is still growing. We're about a year old, and we work with anything that appeals to us. So we have a very open interpretation of what we do, and we're not really looking at apps, and we're not really looking at devices. We're looking at a culmination of hardware and software that is unlike anything people are used to experiencing. So you have surface technology, you have mobile devices, and you have the Kinect as a new emerging platform for interacting with computers. We look at a future where the three combine, and that is where we want that's the direction we choose to head in. So currently we're looking at manufacturing our own Android tablet that has extra sensory perception, so to speak. I'm also doing my master's at the HCI department at CMU. So I saw the Microsoft Surface towards the end of 2009, and one thing that immediately struck me was how visceral it was, how tangible it was. And it's expensive, but it's definitely being marketed in the right way. The Surface revolution threw out a whole bunch of people making their own multi-touch tables and stuff like that. Looking a bit deeper, you could actually question why we can't do that on our mobile devices. Essentially, we have all the hardware we need. And I think Surface interaction is way more fun than anything else that we normally use. Windows and iOS really do a great job with multi-touch per se. So you can independently manipulate different interactors on the screen. You could scale one while you'd be rotating the other. There are a whole combination of interactions that are possible. But can we do this on Android? And the answer is no, you can't. Not really. I think Android was designed with such a tunnel vision about being on a mobile platform that they really didn't imagine where it could lead to. So their vision was always about it's going to be on a mobile phone, and this is how people are going to use mobile phones. If you look at the stock apps that come with Android, you'll always find, let's say the gallery app, you'll always find one picture which you can scale up or down, and most of them can't even rotate it. If you look at the Maps app, there's just one map. Why can't I have two pictures which I can be sliding around, or maybe three maps which I can pan into and probably rotate? Why can't I do that with Android? I'm going to tell you why. So the problem is that Android's touch events are very inaccurate. While you have the ability to understand how many points are actually on the screen, you can't do something as accurate as this. So look at the sketch over there. It says I've touched with one finger on the blue interactor, and then I put my second finger on the red interactor. But what Android will actually tell you is that your second point is still touching the first interactor, which is wrong, and it can lead to all sorts of havoc as far as application development is concerned. This was a really, really crucial flaw in their framework. Another limitation is how rigid Android views and interactors are. So I'm sure all of you are familiar with widgets or buttons, text boxes, stuff that actually build up your UI. Android views are defined very rigidly in a constrained space. So here you can see that that is what an Android view looks like. If you somehow rotate it, it's actually going to get clipped off. And if you scaled it up, it's just expanding, but it's still conforming to those boundaries. It's not really, moving the way you'd expect it to. So we did a lot of thinking about this, and we thought that how do we actually overcome this? It so happened that the solution came in while we were remodeling the office, and they had a whole bunch of sheets of glass lying on top of each other. And the glass actually had some paint on it, and the sheet below actually had some paint on that. And I was like, wait, maybe if we treated Android interactors as sheets of glass with colored content and we merged them together, we could solve this problem. So the approach that we took was to create a different kind of view, to create a different kind of layout, as opposed to what Android's usually used to. So you line things up right next to each other or in relative proportions, and to create a different kind of touch interaction or a binding. So this is what I was talking about. So we thought, imagine that the view is just one single sheet of glass, and the drawn area is actually what you look at. Everything gray over here is transparent, so to speak, right? So only when you touch the drawn area do you actually understand that you're trying to interact with this view. If you touch anywhere outside that, you just ignore it. And when you probably want to move, or when you want to rotate, or when you want to scale things up, you'd still have to just interact with what's drawn in front of you. The interesting was, how do you really understand where that drawn area is? I mean, mathematically speaking, if you rotate it or if you make it larger, there's very little spatial understanding that you can get of a drawing on a single view. So we came up with this interesting solution. I don't know if you can see these colored dots over here. We defined something called a region of interest. For every view, we defined this region of interest, and whenever we got a touch event, we'd see whether that lies in the region of interest, and we process it accordingly. I know it's a bit esoteric, but it'll make sense. So you can see that as long as I'm touching within the bounds of the region of the interest, I'm actually able to interact with the view in some way. When you take multiple views and stack them one on top of the other, and if you look down at that sheet of glass from right from the top, they all kind of look like they're lined together in one space. So it's like a three-dimensional structure pushed into a two-dimensional boundary. So you can see here that there are about three layers. There are three views which are stacked one on top of the other, but on the screen they actually appear as three distinct entities, right? So this was what actually made everything work. And you can interact with each one of these. So when I touch somewhere on the screen, I actually check whether that touch point lies in the colored area. If not, I'll check with the next view. If not, I'll check with the next view. And I'll be able to identify whether I'm really trying to interact with something my eyes connect with. And as far as improving the touch was concerned, what most other frameworks, especially Windows, because that's the touch framework I have worked on, each interactor knows at any given point in time how many points are actually touching it. So in Android, that is really absent. So you touch something, but the view does not know that it's being touched by either one finger or two fingers or three fingers. It has no sense of what's going on. So we actually embedded that logic inside the view, so it knew how many fingers at any point were touching it. And this is what we came up with. So this is running on a Samsung Galaxy Tab, and this was the first variation of the sample that we made. This randomly adds images and allows you to interact with them as if you were on like a Microsoft Surface table. So I could just use 2 fingers simultaneously and manipulate them independently of each other. I could scale one and I could still be able to play around with the other one while all that was going on. So far, this is, nobody I know, or at least I think I know, has been able to do this on Android. And simply because it's just such a complicated task. And you can keep adding more images. And you know, the entire feel of playing around with photographs changes. Now imagine if you could do this with video. Imagine how it would change something like iPages, right? So, so this is what I've been working on. And that's not all that we do at our research lab in India. We're currently hacking the Kinect down, and we've developed a whole vocabulary of gestures that people could use. We've come up with interesting concepts where you could not just use the Kinect, you know, for skeletal tracking, but actually for something more. Where, what if it could identify the surroundings that you were in? What if the Kinect could actually go down into a mobile device someday? And that's the vision we have that we're trying to pursue. So yeah, so why is this guy actually here, and why do we care about all this? Simply because you know, we're doing really cutting-edge stuff, and we have a lot of crowdsourced development. And I think some part of your academic studies just really kind of gets mundane. If you really want to do something different, we have a lot of opportunities. We are trying to come up with development kits for our custom Android tablets about the middle of next year. So we'll have an early developers access program, and I recommend that all of you at least try to be a part of it, because it's going to be a whole new way of experiencing tablet devices, not just through touch, but also through touchless control and through gestures. And there's also money involved. So in our crowdsourced development model, we actually go to academic institutions, we find talented developers such as yourselves, and we offer them an incentive to do an internship with us if they're in the area. And we've had developers who work with us remotely, and we probably pay really well as far as internships are concerned. So you can visit our website. We're about a year old, so and there's so much going on that you won't really find too much on the website as of now. But I think in the coming months, we'll have an expose of everything that we've been doing secretly in the middle of the night. And the reason I'm here is to give all that we have done so far to you. No questions asked, do what you want. All the work that I have done on this is now going to be available to anyone who feels like exploiting it, making a cool app out of it. We want to hear from you. We want to know what ideas you have and what you could do. If you go to this link, it's just a simple web page. There's also a contest that we've organized for everyone. We are actually looking to solve a few problems which currently exist with the framework that we have written. If you think that you can address some of those problems and improve the framework in some way, you could find yourself richer by as much as $200. So please go on and take a look at what's going on. I encourage everyone, if not participate, but really try and get a hold of this and see what you guys can do with it. And that's all I have for you today. Thank you.